Hi everyone. In this video, we'll be taking a look at variables. What's the need for variables? How do you identify what should be a variable? And also, when do we keep variables global and when do we keep them as local? The first and the most important thing is to identify which aspect of your program is varying, because we need to keep a variable to hold the varying value of that item, that aspect. So I have a couple of examples over here. If you have a shrinking or expanding circle that is centered at the center of the display window, then it's the size of the circle that's varying, and therefore diameter is your variable, either diameter or radius, whatever you want. Similarly, if you have a circle or some other shape that's moving left or right, then it's the x coordinate that keeps varying, and therefore x is your variable. And if you have your circle or any shape moving up and down, the y value keeps changing. Y is your variable. This one is a nice one. If your shape's disappearing, then it's the opacity that's varying. So in colors, you have red, green, blue, and then the fourth value is opacity. Okay, and if your shape is expanding or shrinking, at the same time, it's also disappearing, then both diameter because of the expanding or shrinking and opacity because of the disappearing are your variables. If your shape travels in a random direction, so it could be a projectile direction or it could be like a pool table where it's bouncing around, then the shape is moving both in x direction and y direction at the same time. So if you say that the speed in x is 3 pixels every time, and the speed in y direction is -2 pixels every time, then it's going from your perspective to the right and up. So it's going diagonally to the right and up. So that's the need for variables. Now, we keep variables globally for two reasons. Global variable means that you declare them outside any function. So if you declare them outside any function, the variable is visible or accessible by everyone, and its value is retained for the lifetime of the program. So why do you have global variables? Two reasons. The same variable is used in multiple functions, and /or, the value of that variable needs to be retained across several iterations of draw. Because as you know, draw keeps executing over and over. If you declare a variable inside draw, then every single time draw finishes iteration, that variable is erased from the memory. And then again, when it comes to where the variable is declared, it is recreated. So if you don't want that, if you don't want a transient or fleeting variable, you keep it as global. What we are going to do is we're going to create a new program because I don't want to modify my variable template. And the example we're going to take is that of a shrinking circle. At the beginning of my program, and let's say that size of the display window is 600 by 400, so it's a shrinking ellipse. I want my ellipse to fit the screen. So let me just show you a very quick example of how the ellipse should look at the beginning of the program. I'm going to fill it with red and no stroke. The no stroke is purely because of my OCD. Let's comment this out and run my program first. Because I want my ellipse to be at the center of the display window and to cover the entire screen, so fit exactly in the display window, its center is at the center of the display window, which is here, and it's 300 pixels to the right, and then 200 pixels to the bottom. So I can write the ellipse is at center 300, 200, but instead of doing that, I should write width over 2 and height over 2. Because otherwise, if I decide to change the screen size to 300, 500, that doesn't work. But if you keep it as width over 2 and height over 2, once the size is declared, the system variables width and height are updated to 300 and 500 in this case. We also know that the width of the ellipse is the same as the width of the display window, and the height of the ellipse is the same as the height of the display window. So this will give us a fairly decent idea. Let's also change the background to 0 to make it a nice looking background. And you can see that my ellipse fits the window exactly. The good thing about this is that if I change the size of the screen, my ellipse changes accordingly. So this is us not using those magic numbers like 300 or 200 or 700 or 500 in the ellipse statement. All right, next thing. We're going to move this into our draw function because we want to declare it repeatedly. And so now my draw executes, and over and over and over, the ellipse is being drawn with the same width and same height. But as you saw, we would like to shrink it. So it's not the diameter anymore, it's the width and height that should both decrease. Now, unfortunately, we cannot decrease both the width and the height by the same amount, one, because if we do that, then it won't be an ellipse because the proportion is not 1:1. Now, since we have identified that it's the width of the ellipse and height of the ellipse that should change, we can keep them in variables ellipse width and ellipse height. You will note that there is a red line under these keywords because these variables haven't been declared yet. So as my first iteration, I'll declare, and declaring means specifying the data type. So whenever I specify the data type, it reserves the memory. I'll keep the current width as width and the current height as height. I will display ellipse width and ellipse height. I'm going to use print for very specific reasons. Then, for the time being, I'm going to decrease the value by 1. The way you do that is you assign a value to your variable, and the value is the current value, take away 1. Similarly, I want ellipse height to become whatever it is, take away 1. Obviously, this won't work, and we'll see what we have to do in a little while. And then we're going to display the updated values again with a change of line using print ln. Okay. When I run my program, you will see that the ellipse displayed is the same every single time. Its initial size is 700, 500. It does decrease to 699, 499. But because we have declared it in draw, it gets recreated and reassigned to width and height. So we're going to take a crack at this and get rid of it instead of local variable because I want its value to be preserved. We are going to move it all the way to the top, which means it becomes a global variable now. Now you'll see there's a little problem, and we'll see how to fix that in a little while. Now, when I run my program, and I'm going to run it for a short time only, it doesn't start with 600, 400. To slow down my program, I can always change my frame rate to 1. So I just want to change it to, well, let's say 5 frames per second. And in draw, I will erase the background in every iteration because I want to clear the previous output. You will see that my circle starts, but my ellipse starts, but it's not really an ellipse, and also it starts from a very small ellipse rather than the full ellipse. But the good thing is that it is decreasing because it's using the same variable across multiple iterations, And ultimately, it becomes 0. What happens after 0? We're going to take a look at that next week. But one problem is solved. Now let's see why. Let's go all the way to the top, and you'll see that the initial value, so that's your width height. This is your width height. And these are my ellipse width and ellipse height, 100, 100. So it's assigned width because 100, because default width is 100. Similarly, 100 because default height is 100. So as you can see, when a variable depends on width and height, you don't declare it. You don't assign it when you declare it. This is called postponing the initialization. Postpone the initialization until size, until after size, until after size. Once the size is created, then you can say that ellipse width, which is a known variable, becomes width, and ellipse height, which is a declared variable, becomes height. Be very, very careful that you don't redeclare these variables. So please make sure you don't write int or int here, because that would recreate a local variable. So don't redeclare it. Okay, so let's run it now. This is much better. So the ellipse starts from 600, 400. Now I think we can afford to reset the frame rate to what it is originally. So my ellipse starts, and yes, it starts shrinking, but the problem is that it's not shrinking proportionately. So it loses its aspect ratio, so as to say. Now the aspect ratio of this ellipse depends on the aspect ratio of the display window all the time. So what we do realize is that what we actually need is only one variable, ellipse width. Because ellipse height, the height of the ellipse can be calculated using whatever ellipse width is and the size of the display window. So here, we are going to use ellipse width, but ellipse height will remain a local variable. So I'm putting int here, so it means I'm creating it every time and destroying it every time. The benefit of this right now is that I'm calculating the value mathematically correctly. And that is, whatever is the width of the screen, of the ellipse, multiplied by the ratio of height to width. We'll have one problem. You'll see that its height never decreases, and we'll see why that is the case. So now automatically when ellipse width decreases, this value decreases, and therefore this expression decreases in value, and therefore your second ellipse height is automatically lower, or we hope it's lower. So when I run this, you can see that ellipse height is 0 to begin with. I'm going to give you a few moments to think about why is the ellipse height already 0. So it's assigned the value of this expression, which means that this expression evaluates to 0. We know that ellipse width is not 0 because it's there. So it's this expression that's causing the problem. In this case, because height 500 is less than width 700, when you divide an integer by another integer, it's the integer value only. So although 500 by 700 is 0.714, anything after the dot is ignored and it evaluates to 0. We can fix that by first multiplying height by 1.0 and then dividing it by width. The problem that causes is that this becomes a floating point value, and therefore the entire right-hand expression becomes a floating point value, which means that we must keep this as a float. We'll look at casting later, but right now as a float, because we want precision. If I run this now, You can see that my program runs correctly and the values are preserved correctly. And eventually my ellipse reduces to nothing. Also, the ellipse maintains aspect ratio all the time. So this was an attempt from me to explain one more time the use of variables and the several challenges regarding when to keep variables, when to keep them global, when to keep them local. Also, additionally, we learned about why we should keep them as float. So bottom line is that whenever precision matters, you should keep it as float. So coordinate system, size, diameter, radius, etc. should be kept as float. Only values that are definitely going to be whole numbers, like number of cars in your major work, etc., should be kept as integers. I hope you benefit from this video, and I'll see you very soon. Take care.